In this video, we'll talk about the advanced topic of cryptography, and the implementation we'll be talking about will be with the open source program GPG, and it comes installed on most Linux distributions. It's important that an IT administrator understands how to encrypt and decrypt information, because more than likely you will be responsible for ensuring the confidentiality and integrity of the information on a server, and one way to do this is through the use of encryption. So first, let's give a quick overview of the two modes of encryption. The first is called the secret key or symmetric single key encryption, and this is one of the older forms of encryption. Symmetric encryption uses a single key to encrypt a message, and the single key is then shared by both the sender and the receiver. The sender uses a secret key and the symmetric algorithm to encrypt the message, and then the receiver uses that same key to decrypt the message. Note that if this key is compromised, so are the communications, that is, the document that has been encrypted. The second and newer form of encryption is called asymmetric or public-private key. Asymmetric encryption uses a key pair. It creates a public and a private key that are mathematically related. We want to share the public key with others so they can send us encrypted messages that only we can open with our private key. Our private keys are also used to create digital signatures as a way to authenticate a message. This is a graphical depiction of how a symmetric cipher or symmetric algorithm works. On the left, we have our plain text input, and here we're using an encryption algorithm that provides us with a symmetric cipher. And here it's the digital encryption standard, which is the older standard used by the U.S. government. Note that we have a secret key that has to be shared by the sender and the recipient. It's only a single key. So we take the plain text input and we use the key and the algorithm to create something called ciphertext. We can then transmit this ciphertext, which is the encrypted message, to our recipient. The recipient then uses the shared secret key along with the decryption algorithm, which is simply the reverse of the encryption algorithm, which in this case would be the digital encryption standard, in order to decrypt the message. This plain text output will be exactly the same. On the other hand, we have public-private key models. In this instance, we have both public keys and we have a private key. It's called a private key because this is something that we want to remain a secret, and this private key should not be shared with others, and it should be protected by a very good passphrase. Notice here that we have something called a public key ring. In this instance, it's Bob's public key ring. Notice that this public key ring has numerous public keys from recipients that Bob may be interested in sending an encrypted message to. We have Joy, Mike's, Alice's, and Ted's public keys. In this instance, Bob wants to send an encrypted message to Alice. So Bob uses Alice's public key along with an encryption algorithm, in this instance the RSA encryption algorithm, to encrypt a plain text input, which results in ciphertext. This ciphertext is then sent to Alice. Alice uses her private key then, along with the decryption algorithm, which is just again the reverse of the encryption algorithm, in order to decrypt the message. Note that only Alice can decrypt this message. That is, if Alice's public key is used for encryption, only Alice's private key can be used to decrypt the message. So let's talk about the implementation that we're going to be using, GNU-PG, also called GPG. GPG is an open source public-private key software that's freely downloadable. GPG doesn't come with a graphical user interface. Most of the commands are run from the command line. However, there are third-party user interfaces you can download to make the process a little easier. But for our demonstration, we're going to do everything from the command line. GPG implements both several types of symmetric algorithms as well as public-private key algorithms. Technically, GPG uses a hybrid system for its public-private key system. We can then use GPG for both encrypting and decrypting messages, either using symmetric or asymmetric algorithms, or we can create digital signatures for signing a document and having the recipient being able to authenticate that we were the actual senders of the information. The first thing we need to do is to create our own public-private key pair, and we do this with the command that you see right here. Another important thing we want to do is to create a revocation certificate. We create a revocation certificate using this command right here. We want to make sure that we save our revocation certificate as a hard copy or save it someplace where it can't be stolen. But realize once your private key is stolen, if someone does guess the passphrase, they would be able to pretend that we're us. So let's go ahead and let's just type GPG and see what happens. We haven't created a public-private key prior to this, and so GPG goes and creates a hidden directory called GNU-PG, which will hold our public-private key files as well as a trust database. It also creates a GPG configuration file where we can provide certain configuration options, for example, the default type of symmetric algorithm to use, or whether we want to always use the -- armor flag, which we'll talk about later. It goes ahead and it creates a empty secret key ring, secring.gpg, and also an empty pubring.gpg. The sec ring will hold our private keys, and our pub ring will hold all our public keys. And then it says go ahead and type your message. Well, we don't have a public-private key yet, and we're not ready to do that, so we need to hit Control-C to stop the process. And so that was unnecessary to do because we could have just gone ahead and started the process of generating our key, which we do with this command. And we hit enter, and the process of creating the public-private key begins. It first asks us to select what kind of key we want to create. Notice that there are 4 possibilities in here. The default is to create an RSA public key, private key, and also a signing key. So this is the default, and you can create any of these you want, but let's just go ahead and let's select the default because that should be fine. Symmetric and asymmetric cryptography models are based on different mathematics. While a symmetric algorithm may use a key of length, for example 128 bits to 256 bits, public-private key algorithms use much longer keys due to the different mathematical model underlying them. In this instance, the keys range from 1024 bits to 4096. Note that a 4096-bit key will be much stronger than a 1024-bit key. Notice that the default is 2048, which is fine. And so we'll select the default and just hit enter. And now we're asked as to when we want our key to expire. In a lot of instances, we might not want our key to expire, so we'll just use 0 here. But for this demonstration, we're going to have our key expire in 5 days. And this is just for this demonstration here. If you look at my public key that's listed on some of the key servers, I do not have an expiration date on my public key. And so it says the key expires Sunday, December 5th, 2010 at 10 a.m. Eastern Time. Is this correct? Notice that the default is no, but we're going to hit a Y for yes. And now we need to provide some user identification information for the key. And this is important because this information will be included in our key, and it's one way to indicate who is the owner of the key. And this gives an example of the 3 pieces of information that we will include: the person's real name, and then there's a comment you can include, which is optional, and also an email address. The email address is important because each email address is a unique identifier for a person. And so let's go ahead and use our real name here, hit enter, our email address, and I'm going to use my Gmail address, enter comment, and again the comment is optional. So we've listed our real name, our email address, and make sure that email address is correct, because that's how one of the primary ways that people can search for our keys on the key server. We hit enter, and this is what our user ID for the public key will look like. And we can change the name here, or the comment, or the email address. We can hit O for OK, or Q for quit. I'm going to say OK. And don't worry about this GPG agent, is not available in this session. GPG agent is an add-on that makes the use of using your public key a little easier by keeping that stored in memory, but we don't need to worry about that now. Now, the passphrase is not used for your public key, it's used to protect your private key, and so you want a really good passphrase. Usually a good passphrase is one that is at least 8 characters, preferably more, that contains both upper and lowercase letters, numbers, and a special character. And you're going to need to remember that, because you will not be able to recover your private key if you forget that passphrase. Now GPG is looking for random data created by the system in order to generate the public-private key, and you can read all about this here. It says it needs 284 more bytes in order to create the public-private key. So we're trying to create some entropy here, so it asks us to type or move the mouse around, so we can move the mouse around. And it might be a little slow if you're running this in VMware. And we can do some typing, just random typing, and move our mouse around. And after all that, we see that GPG has created a trust database. We'll talk a little bit about that later. It's also created a unique identifier for our public key, and that's in hex, and that's what this is right here. And so when someone that wants to download your public key, they can either refer to it via your email address, which is a unique identifier, or this unique combination of hexadecimal characters. Notice GPG said that it created a public and a secret key, and that the secret key was signed. It checks a trust database, which it shouldn't have any trust in here as yet. And it tells us the information about our public key and our signing key, which is our private key. This says that the public key is 2048 bits using the RSA algorithm. This is the unique identifier. This is when it was created, and this is when it expires. The key fingerprint. The key fingerprint is a hash of your public key, and it uniquely identifies the contents of it. Notice also that the last bytes of this correspond to the unique identifier that's listed up here. It also lists our user ID information, my name, my comment, and my email address. And it also indicates the subkey, which is the private key, which is a 2048-bit RSA private key, and this is the unique identifier for it. Notice also it indicates when it was created and when it expires. And because the system was so slow that the rest of this that I was typing was actually Linux tried to execute it after I typed it. So occasionally you'll see this. Let's hit Control-C and clear to get out of this. Now, if you want to know how GPG works, if you need to know some of the options available to it, there's 2 different ways of finding that out. One is with the manual page for GPG. And it's a very good manual page that tells you pretty much everything you need to know about GPG. And there's also the GPG manual that comes in PDF format, and I will make sure that I upload that to the website. But that's also a very good source of information about GPG. Let's go back to our notes. The next thing we want to do is first we want to create that revocation certificate. If you recall, we need that revocation certificate, which we will then post on a key server if our private key is ever compromised. That is, it's stolen and if somebody is able to guess the passphrase. And so let's go do that now. Let's go back here, type Q to get out of that. And let's use the man page to find out how to create the revocation certificate. So let's / and let's search for the word revoke. And we see that the command is -- revoke and then the name or user ID. So here we can either use that unique hexadecimal identifier, or we can use the email address as the identifier. So let's get out of this and let's create our revocation certificate. Revoke, and it was philip.kreger@gmail.com, and it finds our key on the secret key ring and create a revocation certificate for this. Notice the default is no, so we type a Y. Please select the reason. If you're doing this right after you create your public key, private key pair, you're not going to know whether, you can't answer this. Your key has been compromised, key is superseded, key is no longer used, and so on. So usually you're going to put a 0 in here. If you create your revocation certificate after your key is compromised, then you could go back and create the revocation certificate using one of these 3 options. But we're just going to put a 0 here and enter an optional description, and we'll leave that as blank. End it with an empty line. Hit enter. Reason for revocation, no reason specified. Is this okay? Yes. And now we need the passphrase to unlock the secret key. Notice that it says for user, and that is the correct user ID for the key we want to revoke. And we type in our secret passphrase, and there's our revocation certificate. Unfortunately, it didn't write it out to a file, it wrote it out to the screen. If we were to go back and do this again, we could type out that we want to call this revoke.asc or GPG, and that would indicate that this is the revocation certificate for that user ID. Now the next thing we want to do is we want to export our public key, because the encryption, if anybody wants to encrypt a file and send it to us, they're going to need our public key. And so we create this by typing GPG -- and our unique user ID, and then out that to a file called pubkey.gpg, and we want to include our name in here. This is going to create a binary file, and we'll take a look at that in just a second. And remember, the public key we want to share. It's the private key we want to keep secret. There can be problems with sharing a binary file, so GPG provides an alternative, which actually ends up being the exact same key, only it uses a text encoding so that it's easier to share, or let's say even include in our email address. And so somebody could import our public key if they downloaded it from an email. And the flag or the option to use is --armor, GPG --armor export, the unique user ID, and then the name of the public key .asc. So we usually use the GPG extension when we have a binary file, and to make it clear that it's an ASCII armored file, we use the -asc. We'll go ahead and we'll create both and take a look at them. So let's clear this, and now let's type GPG export and our user ID. I always use my email address .com, and then greater than, we're redirecting it to a file called Philip Kreger pubkey.gpg, and this is going to create the binary file. We hit enter, we get no feedback. Let's take a look at the contents of that file with XXD, which is a hex viewer. And this is our public key. Notice that it does have some information in ASCII text. And the rest of the key is going to be what pretty much looks like random data, but that's our public key. If we run the file command on that, notice that the file command is able to determine that it's a GPG public key. Now let's go back, and instead of exporting this to a binary file, we're going to change that so it's an ASCII file. And remember, these are, it's still your public key, it's just in a different format. We use the -- armor option on that. We hit enter, and now we can just cat the file. Let's just go ahead and type ASCII, it should be the only one there. And you've probably seen these all over the internet. But notice this is the public key. Notice that our username and information is no longer included in there in ASCII text, but it's still included in there because this is encrypted as well. But this works exactly the same as the GPG file, only it's ASCII armored is what it's called. This also tells you the version of GNU PG that was used, 1.4.10, and that it was created on a GNU Linux system. And now what we want to do is we want people to be able to access our public key. One way we can do this is we can send the public key to a user, for example, as an attachment or as an email, or you can send it to a key server. And there are probably hundreds of different public key servers around the world. Ubuntu has their own, and MIT has one. Or you can send it to a key server that you've indicated in your configuration file using the command gpg-send-key, and then the user ID, which would be your user ID, in this case philip.kreger@gmail.com. Notice this is jumping ahead a little bit, but put the fingerprint of your public key in your email signature or your business cards. What this allows people to do is to check the fingerprint of the key to make sure that it's, when they download it from a key server, that it's actually your key. Let's go take a look at a key server. I'm in Google and I've just typed the keyword key server, and you notice that it starts listing the most prominent key servers in here: keyserver.pgp.com, keyserver.ubuntu.com. And let's go to the Ubuntu key server, and they all look the same. And the key servers also will update the public keys that have been uploaded with the other key servers, so they're consistent across key servers. Notice that you can submit a public key down here, submit a key with your ASCII armorized version, so you can just copy it and paste it in here. Or you can search for somebody's public key. So the search string you're going to be using is something that's going to uniquely identify the user. So that's going to be the email address, or it's going to be their hexadecimal unique ID that's associated with the public key. I'm not going to upload the public key that I just included in there because this is just for demonstration, but my actual long-term public key is tied to my internet address, philip@kreger.net. Let's hit submit. And here's Philip. Here's my public key, and this is all the verification that's been done on the key by the key server. And if we click on this, notice this is my unique identifier. And there's the key right there. It tells you the date that I created it. It's a 1024-bit DSA key algorithm. And there's my public key. If you'd like to retrieve this, you can use either my, as I said again, my email address or the unique identifier you saw on the previous page. But there's my public key. And I know it's a little advanced topic, but there is also a way to include a picture of you in your public key. And that's why mine is so long, because it does have a picture of me in there. But that's my public key, so if you ever want to send me anything confidentially, you can download this public key and import it into your key ring, and then use that to send a message to me confidentially. Let's go back to the notes. And so, if you want to acquire other people's public keys, the easiest way to do that is if they've published their key to a key server, is you can download that manually. And you should also check the fingerprint of the key to make sure that that fingerprint is the actual fingerprint of the public key you've downloaded. And the way to check somebody's fingerprint is to run GPG, and that should be a dash dash. PowerPoint is so good about changing dash dashes to long dashes, so it should be GPG dash dash fingerprint UID, and then we'll check the fingerprint. And then we use the out-of-band channel, a phone call, or preferably not an email, but you could use that to check to make sure that the fingerprint actually matches. Now, of course, if you want to send a confidential communication to somebody, you're going to need their public key. And there's several ways to import a key or to acquire a public key. I've already said that you could download that from the key server, as we just saw previously. Or if in your configuration file you've indicated that you want to use a particular key server, like the Ubuntu key server, from the command line we can use GPG -- receive keys and then the unique identifier of that key. And this is just a fictitious key that I created from here. Or if somebody has sent you a file, you can import it directly using GPG -- import Phillips pubkey.gpg, and then we want to confirm the fingerprint using GPG -- fingerprint UID. So let's take a look at that. So on another system, I've created another public key, and then I've copied it over to my Ubuntu system in here, and let's see what I've called this. I've created one called philip.gpg, and so what I need to do is I'm going to import this philip.gpg, and GPG tells us what the unique identifier is. Notice that's different from all the other unique identifiers we've seen with the other 3 public keys I've created. It's got my name and my comment and a different email address. GPG indicates it was imported, the number of total keys processed, a single RSA key. Now, if we want to check the fingerprint of that, we can type GPG fingerprint, and let's use this time the unique identifier here. So 0818858. And this tells us more information. It tells us the public key, the size, the unique identifier, when it was created, when it expires, and there's our key fingerprint. And so now we can ask the person, what is your key fingerprint? And we could call them, and if they told us it was 4351 A42C, etc., we would know that that is a good public key. So we know we have a public key ring, and we've imported a single public key. If we want to list all the keys in your key ring, we use GPG list keys, and it shows all the keys including your secret keys. If we would like to see all the keys with the signatures, that is the keys that other people have signed to indicate a level of trust and authenticity of the key, we can type list -sigs. If for some reason we want to delete a key, that is, it's no longer be used, we can use this command here.